Welcome back. This is Advanced RAG Part 4a Smarter Queries. In the earlier parts, we built a working RAG pipeline, indexing documents, embedding queries, retrieving chunks. Now it's time to look at where that pipeline breaks. Let's get into it. Same database, same chunks. The answer is right there, rank 4. But most systems pass only the top 3 to the LLM. So the answer exists in the database but never reaches the model. This isn't a storage problem, it's a retrieval problem. And there's enough to fix here that we've split this into two parts. Part 1 covers smarter queries, Part 2 covers smarter ranking. In the last video, we fixed chunking, the input side. Documents split intelligently, stored correctly. But retrieval still breaks, not because the database is wrong, but because the query doesn't match how the documents are written or doesn't land in the right neighborhood of embedding space. Today we fix two specific failure modes, both on the query side. Here's the first failure mode. The user asks about days I don't use. The document says unused vacation days rollover. Same meaning, different vocabulary. The embedding captures some of the similarity, 0.64, but not enough to rank in the top 3. The answer exists, the search misses it. Fix query rewriting. Before the query hits the vector database, an LLM rewrites it, expanding abbreviations, adding synonyms, making the intent explicit. Days I don't use becomes PTO unused vacation rollover policy. The embedding now matches. The document jumps to rank 1. Take it further. Generate 3 different query variations. Each approaches the question from a different angle, uses different keywords. Search with all 3, merge results. You catch documents that any single query would miss. Here's the code. One function. The LLM reads the vague query and outputs an optimized search query. Synonyms added, intent made explicit. We use GPT-4o Mini. This is a lightweight task, no need for a big model. The rewritten query is what gets embedded and searched. Search with the rewritten query. The PTO rollover policy, which was buried at rank 6 with the original wording, is now rank 1. Same database, same chunks, same model. Better query. Second failure mode, the semantic gap. Questions and documents are written in fundamentally different styles. How do I get money back for a work trip is a question. Submit receipts via the finance portal within 30 days is an answer. Even though they're about the same topic, they sit in different neighborhoods of embedding space. The embedding model gets close, but closer isn't always close enough. Here's the idea, and it's clever. Instead of embedding the question, ask the LLM to generate a hypothetical answer first. It doesn't need to be correct, just linguistically similar to what the real answer would look like. Now embed that hypothetical document. Its embedding lands in the document cluster, right next to the real answers. The hypothetical is never shown to the user, it's purely a search probe. HyDE shines on vague queries where the user doesn't know the right terminology. But it can backfire. If the LLM hallucinates specific details in the hypothetical, say 16 weeks of parental leave when the real policy says 12, the embedding is now biased toward the wrong number. HyDE is the most variable technique in this video. Test it on your data before committing. Let's look at the code. Step 1. Generate the hypothetical. The prompt is specific. Write as a company document, not as a chatbot. Step 2. Embed the hypothetical document. This is the key insight. We are embedding the fake answer, not the question. Step 3. Search with that embedding. Without HyDE, the query about money back for a work trip retrieves a document about booking travel. Related but wrong. With HyDE, the hypothetical bridged the vocabulary gap. Money back became reimbursement. Work trip became business travel. The actual expense policy is now rank 1. And with that, two of the three retrieval failure modes are solved. There's one more, and it's about what happens after the search returns results. Query rewriting and hide fix how the query enters the vector space. But look at the original hook again. The answer is rank 4, not because the query was bad, but because embedding similarity and true relevance are two different things. In part 2, we fix the ranking itself with a cross encoder re ranker, the single highest ROI upgrade in this whole series. Full code and notebook in the GitHub repo, link in the description. Part 2 is already up, re ranking, the full pipeline, and when to use each technique. See you there.